In this video, we're going to discuss arithmetic sequences. A sequence is basically just a list of numbers. Let's say 1, 3, 5, 7, ... or 2, 4, 6, 8. Those are all sequences. An arithmetic sequence is a list of numbers that between each term in the list, we are adding some number. We're not multiplying the term by something, we're adding something. So the both sequences that I wrote are arithmetic sequences. The first one, we're adding 2 to each term, so 1 plus 2 is 3, 3 plus 2 is 5, 5 plus 2 is 7. We're adding the same thing in between each term to get to the next term. So if we wanted to continue the sequence, we would just add 2. 7 plus 2 is 9, 9 plus 2 is 11. And the second sequence that I wrote is also, we're adding 2 plus 2 plus 2 plus 2. If we wanted to continue, we would do 8 plus 2 is 10. We could also be adding a negative number. So let's say we have a sequence 10, 7, 4, ... It looks like we're subtracting. What we're really doing is we're adding a negative number. We're adding negative 3 between each term. So the next term would be 4 plus negative 3, which is positive 1. And the term after that would be positive 1 plus negative 3, which is negative 2. Those are all examples of arithmetic sequences. When we have an arithmetic sequence, each term is in its own place. So the first term, we call it a sub 1. The second term, we call it a sub 2. The third term, we call it a sub 3, and so on. So let's say the first sequence that I wrote out, 1, 3, 5, 7. A sub 1 would be 1, a sub 2 would be 3, a sub 3 would be 5, and if we would continue going, a sub 4 would be 7, a sub 5 would be 9, and so on. The a sub 1, the a sub 2, the a sub 3, the a sub 4, the a sub 5, those numbers just represent what number term in the sequence is that value. So the value 5 is the third term in the sequence because it's a sub 3. When you have an arithmetic sequence, there are two ways you can define it. You can either define it recursively or explicitly. The recursive definition of an arithmetic sequence is a sub n is equal to a sub n minus 1 plus d, and you have to be given a sub 1. So what does this mean? A sub n is what we're solving for. A sub n minus 1 is the term before the term we are solving for. D is the common difference, which is the number that we're adding between each term, and we're given a sub 1, we're given the first term. So let's say we have a recursive sequence. A sub n is equal to a sub n minus 1 plus 4, and we're given that a sub 1 is equal to 1. What does this mean? Let's say we wanted to write out the first 5 terms in this sequence. A sub 1, the first term, is 1. A sub 2, to get a sub 2, we're going to solve this equation for a sub 2. So a sub 2 is equal to a sub 2 minus 1 plus 4. Wherever we see an n, we're plugging in the value of the place. So the second place, a sub 2, is a sub 2 minus 1 is a sub 1 plus 4. A sub 1 we already know is 1 plus 4. So a sub 2 is equal to 5. So what did we do? Wherever we saw an n, we plugged in the place value of that term. So to find the term in the second place, we plugged in the 2 for n. Wherever we saw an n, we plugged in a 2. Then we simplified, and we already have a sub 1, so we're able to plug that in. Let's say we wanted to find a sub 3. So for a sub 3, wherever we see an n, we're plugging in a 3. So a sub 3 is equal to a sub 3 minus 1 plus 4. A sub 3 minus 1 is a sub 2 plus 4. A sub 2 we already know is 5. 5 plus 4. So a sub 3 is equal to 9. Let's find a sub 4. A sub 4 is a sub n minus 1 or a sub 4 minus 1 plus 4. A sub 4 minus 1 is a sub 3. A sub 3 plus 4. A sub 3, we already solved for before, is 9. 9 plus 4 is 13. And let's solve for a sub 5. A sub 5 is equal to a sub 5 minus 1 plus 4. Or a sub 5 is equal to a sub 4 plus 4. And a sub 4, we already know, we already solved, is 13. 13 plus 4 is equal to 19. So these would be the first 5 terms of our arithmetic sequence. And we know that the common difference is D, which is 4. And that makes sense. We could check to make sure we got the right terms. If we add 4 to 1, we get 5. If we add 4 to 5, we get 9. If we add 4 to 9, we get 13. If we add 4 to 13, we get 19. And we could continue going by just adding 4. The problem with using an arithmetic sequence is, let's say you wanted to find a sub 20, the 20th term in the sequence. You would have to use a sub 5 to solve for a sub 6, then use a sub 6 to solve for a sub 7. There's no way to easily jump to the 20th term. You have to find each term before the 20th term in order to find the 20th term. Because let's say we tried to solve for the 20th term. We would do a sub 20 is equal to a sub n minus 1, so a sub 20 minus 1, plus d, which is plus 4. So a sub 20 is equal to a sub 19 plus 4. But we need to have a sub 19 in order to solve this. And what's a sub 19? A sub 19 is equal to a sub 19 minus 1 plus 4. A sub 19 is equal to a sub 18 plus 4. But we need to have a sub 18 in order to solve for what a sub 19 is. So for each term, we need to have the term before it. So we will need to find all 20 terms before a sub 20 in order to find the 20th term. Therefore, instead of doing all this work, we also have something called the explicit form of the sequence. To use the explicit sequence, we do not need to have the term before each term in order to solve it. The explicit sequence, you don't need to memorize it. It's given to you on your formula sheet on the Regents. And it is a sub n is equal to a sub 1 plus n minus 1 times d, where a sub n is the term that you're solving for. A sub 1 is the first term. N is the place of the term that you're solving for. Let's say the first term, the second term, the third term. And d is the common difference. So let's look at an example. Let's say we have a sub n is equal to 3 plus n minus 1 times 2. The first term is 3, and the common difference is 2. So the common difference is what we're adding between each term. Let's say we wanted to find a sub 20. Let's say we wanted to find the 20th term. We would do a sub 20 is equal to 3 plus 20 minus 1 times 2. So a sub 20 is equal to 3 plus 19 times 2. And 19 times 2 is 38. 38 plus 3 is 41. Using this explicit formula, we were able to find the 20th term of this sequence without solving for the 19th term or the 18th term or the 17th term. On the Regent, you might be asked to write either a recursive sequence or an explicit sequence for a given situation. Let's say you're given on the Regent that the first term of a sequence is 10, and the common difference is 3. Let's say you're asked to find a recursive sequence and an explicit sequence. Let's start with a recursive sequence. The formula for a recursive sequence is not given to you on the Regent, so you'll need to memorize it. The formula for any recursive sequence is a sub n is equal to a sub n minus 1 plus d when you're given a sub 1. If we wanted to write a recursive sequence for the given terms, we're going to write a sub n is equal to a sub n minus 1 plus the common difference, which is 3, given a sub 1, which is equal to 10. This would be your recursive sequence for the given situation. Let's say you wanted to write an explicit sequence. All arithmetic explicit sequences look like a sub n is equal to a sub 1 plus n minus 1 times d, and you don't need to memorize that formula, it'll be given to you on the Regent. A sub n is equal to, let's fill in what we know, a sub 1 is the first term, which is 10, plus n minus 1 times d, the common difference, which is 3. Now we want to simplify this to make it look nicer, to make it look more like a regular equation. So we're going to distribute the 3 over the n and over the negative 1. So a sub n is equal to 10 plus 3 times n is 3n, 3 times negative 1 is negative 3, and then we can combine like terms. So a sub n is equal to 10 minus 3 is 7 plus 3n, and this would be your explicit sequence. Another way to write the recursive sequence or the explicit sequence, instead of writing, let's say, the recursive sequence as a sub n is equal to a sub n minus 1 plus d given a sub 1, it might be written as f of x is equal to f of x minus 1 plus d given f of 1, and this means exactly the same thing, but instead of writing a sub n minus 1 and a sub n, we're writing f of x and f of x minus 1. And for the explicit sequence, it's the same thing. Instead of writing a sub n is equal to a sub 1 plus n minus 1 times d, it might be written as f of x is equal to f of 1 plus x minus 1 times d. But this means exactly the same thing.